this improper integral is simple than it looks. So we have the integral of 1 over x squared with respect to x with the limits 1 to infinity. So the rule says this integral, right, when we raise it to the power p, when x raised to the power p is finite, that is, does not diverge, if and only if p is greater than 1. So in this case, we can see that our p is equal to 2. So this limit converges. Now that we know that the integral converges, let us go ahead and find its value. So we can write this as the limit as, say, b goes to infinity. Where there is infinity, we put b, then we maintain our 1 here, right? And we can write this as x to the negative 2 with respect to x. So I just write 1 over x squared as x to the negative 2 so that I can find its integral. This is the same as the limit as b goes to infinity of, let us go ahead and find the integral of x to the 2. When we add 1, it becomes divided by 1. So this is negative x, then to the power negative 1. And the limits are just b1. Okay. Now this is the same as, I can take the negative out and find the limit as b goes to infinity. And this is just the same as, so the negative is outside, so I put b, it's just the same as 1 over b minus 1 divided by 1 is just 1. Now we can see here that we have the limit of 1 over b as b goes to infinity. So you know that 1 over b goes to 0 when b goes to infinity. So you have 0 minus 1, which is just minus 1. Then you multiply by the negative 1 outside. This becomes positive 1. This is the type B integral where the p is less than 1 and the integral converges. So you can see here that what is bad here is the integrand. The limit is finite, that is 0 to 1, but the integrand 1 over x to the power 3 is bad because when x is 0, this thing becomes undefined. So it is also an improper integral. So what we're going to do is that we are going to find the limit as, say, b goes to 0 from the right. Okay, why from the right? Because everything between 0 and 1 is good, except when we are approaching 0 from the right. Where there's 0, we put b and 1 remains. So I can write x to be to the power 2 over 3, and this is with respect to x. Let's go ahead and find this integral. So when we add 2 plus 3 plus 1, just same as 3 over 3, which is just what? Which is just 1 over 3. Okay, but we're dividing throughout by 1 over 3, so it is the same as multiplying by 3. Let us go ahead and factor out 3. This is 1 minus b to the power 1 over 3. So you can see here as b goes to 0, this goes to 0, so this is just 3. We have 4 integrals, which one converges and which one diverges. So the first two, these are bad integrals in that their limits is infinity. You can see here the limit is 1 to infinity, which is the bad limits. Then the second one, we have bad integrand. Why bad integrand? Because if you divide by 0, this becomes undefined. Division by 0 becomes undefined. So the first one, the limits are bad. The last two, the limits are good, but the integrand is bad. So if the limits are bad, you just concentrate on the power, right? You just concentrate on the power. The p has to be greater than 1. And in this case, 5 over 4 is greater than 1. So this guy converges. Here you have 3 over 5. So p is less than 1. So the limits diverges. So this one diverges. In the third one, we said the limits are finite, but the integrand is bad. So here, you want your p to be less than 1. Okay? So because here p is greater than 1, this thing diverges, right? This thing diverges. It goes to infinity, whatever it goes to, diverges. Then the last one, p is less than 1, so this is a good integral. It converges. Let's see whether this integral converges or diverges by the comparison test. So we are comparing these two functions. So we have x to the power 5. We know that this is less or equal to x to the power 5 plus 3. This is obvious, right? So if this is the case, then we know that we can take the reciprocal of this function. So this becomes 1 over x to the power 5 plus 3 is less or equal to 1 over x to the power 5. So how the comparison test works is that if the upper function here, right, if the bigger function converges, then the lower function converges also. If it diverges, the other function converges. Okay, so obviously we have, let us compare this. We have 1 to infinity of 1 over x to the power 5 dx, right? So by the p test, you know that this converges if p is greater than 1. So obviously 5 is greater than 1, so this limit converges, and this limit is finite, right? It converges.